10-1 is areas of squares and rectangles. And when I go over this, I'm going to wide out the work, and I'm going to do this work with dimensional analysis. I want us to see it that way. So we're going to show our work maybe a little bit different here than the textbook is showing it. The formula for every square is side square, or S square. So there's our formula. We have 3 squares. One of them has 1 diagonal shown. One of them has 2 diagonals shown. And we'll talk about the properties that exist because of that. Notice on the first it's in milli, and we want to convert to centi. The second one has no units of measure. The third one is in feet, and we want to convert it to inches. So we'll remember that as we solve these. I'm going to wide all this out so we can just focus on the work and have plenty of room to look at it, and we can think about the dimensional analysis approach to solving. So if we wanted to find the area, we would use our formula. Area is side square. What I would have done in algebra is have you write that on a word sentence line and then plug into that formula. So we would have plugged in and got area equals side, which is 7 millimeters quantity square. Now, exponential law or distributive law summed up on page 171 says you can distribute an exponent on the multiplication. That's like 7 times millimeter. So we're going to have 7 square millimeter square. We square them both. 7 squared is 49 millimeter square. That's the area in square millimeters. But it asks for the area in square centimeters. And we're going to convert using the dimensional analysis approach in this entire text. The dimensional analysis approach is to try to lose the name milli, gain the name centi. We're trying to go from milli to centi. We need to multiply such that we lose what we have on top and we gain what we're looking for. We're going to lose the name millimeter square. We're going to gain the name centimeter square. So then we say, which one's the bigger? Well, centi. How many of the little ones makes the big one? 10. 10 milli is a centi. But we're not dealing with milli and centi. We're dealing with square milli and square centi, so we square those conversions. 1 squared is 1. 10 squared is 100. And so we have a 1 and a 100. When we multiply, we're going to have 49 times 1 is 49. And the name centimeter square, the name milli disappeared. And we multiply the denominators, 100. If you take 49, divide 100, and get a decimal, you would have 0.49 square centimeters for the area. Okay? Let's see how we got that. Perimeter. The perimeter is the sum of the sides, or the distance around. So it'd be side plus side plus side plus side. S plus S plus S plus S is 4S. So the perimeter is 4S. Each side is 7 millimeters, so we have 4 times 7 millimeters. You're going to multiply the numbers. 4 times 7 is 28. And the name millimeter tags along. So that's the answer to perimeter in millimeters. Notice perimeter is 1 dimension, so it's millimeters to the first power. Area is 2 dimensions, length and width. It's in square millimeters. So we want to convert from the name milli to the name centi. So we want to lose the name milli and gain the name centi. This way, that name milli cancels. So we say, well, which one's the big one? Centi, so we make it a 1. How many of those little millis is in a centi? 10. We've got centi to the first and milli to the first, so we leave those dimensions like they are to the first power. We multiply what's left. 28 times 1 is 28, and we gain the name centi. 1 times 10 is 10. If you divide by 10, you're going to have 2.8 centimeters. Any questions on number 1? So the formula for area of a square is side square. You need to have that memorized. The formula for perimeter of a square is 4S. On most standardized tests like TAKS or end of course, the formulas for square are not given. These are formulas you have to have committed to memory. They will not be given to you on a formulas chart. So be sure you commit those to permanent memory. Now, I'm requiring you to know every formula in this chapter by memory. Okay? Your teacher may let you use a formulas chart. For my students, if I'm teaching geometry, you will have to know you'll have to know these formulas. Okay? Number 2. Now, number 2, again, we're dealing with a square. There's some properties we know of a square. Each angle of a square is 90 degrees. Each diagonal bisects a pair of opposite angles because the square is a rhombus, and if you bisected a 90-degree angle, you get a 45-degree angle. So when you draw a diagonal on a square, you end up with a 45, 45, 90 triangle. Now, we want to find the perimeter and area, so we need to know the length of a side, so I'm just going to call that S. To find S, we're going to use our 45, 45, 90 triangle rules, which means it says the legs are equal, and the length of the hypotenuse is equal to the length of a leg times the square root of 2. We know the hypotenuse 5 square root 2. We're looking for the leg, which is the side. To solve, we would undo multiplication by division. We're getting rid of the square root 2 on the S. It also cancels here, and we have S equal 5, which was obvious. So each side is 5. If we want the area, the formula for area is side square. We plug in the length of a side 5. We get area is 5 squared, which is 25. If we want perimeter, perimeter is 4S, the sum of the sides. So the perimeter is 4 times a side, which is 5. And so the perimeter is 20. So we remembered the properties of a square and came up with a 45, 45, 90 triangle. We remembered our 45, 45, 90 triangle rules and came up with the length of a side. We plugged those into our area and perimeter formulas and found the area and perimeter. Number 3. Number 3 is in feet. We're going to eventually change it to inches and square inches, so we're going to remember those conversions. You're supposed to memorize inches to feet, feet to yards, yards to miles. We're supposed to know all the properties of a square. A square is a rhombus, which means that the diagonals are perpendicular and bisect each other. It's a rectangle, so all 4 diagonal pieces are equal, so every little diagonal piece is 4 feet. Each diagonal bisects a pair of opposite angles because it's a rhombus, and each angle is 90 to start with because it's a rectangle. So we get a whole gob of 45, 45, 90 triangles. Now, I'm just going to take one of those out. If I take one of those out, then that's 90. This is 45. This is 45. The leg here is 4 feet, and this is the length of a side of the square. If I'm going to find perimeter and area, I need to find the length of a side, and I'm going to do that with the 45, 45, 90 triangle formula, that the hypotenuse is equal to the length of a leg times the square root of 2. So the hypotenuse, which is the side of the square, is equal to leg, which is 4 feet, times the square root of 2. And so we get that the length of a side is 4 square root 2 feet. So we've got the side, so now we can find the area. I'm going to bring it way over here. So the area is side square, which would be 4 square root 2 feet square. Now, according to exponential law, that exponent will distribute onto the multiplication. And so we're going to have area is equal to 4 squared is 16 times square root 2 squared. That square would cancel the square root and you'd get a 2 times feet square. See that? 4 squared is 16. Square root of 2 squared is 2. Square cancel square root. Feet squared is feet squared. Multiply 32 square feet. So the answer to area in square feet is 32, but we don't want the answer in square feet. We want the answer in square inches. So we're going to multiply such that we lose the name square feet and gain the name square inches. So we say, which one is bigger? Well, square feet is bigger, so we put a 1. How many inches are in a foot? 12. But we're not dealing with inches and feet. We're dealing with square inches and square feet, so we have to square those conversions. 1 squared is 1. 12 squared is 144. We're losing the name square feet. We're gaining the name square inches. So we're going to have 32 times 144. 32 times 144. I may just calculator that one right quick. $4,608. And we gain the name square inches. Any questions on the area? Perimeter. The perimeter is 4S. I generally say put it on a word sentence line in Algebra 1. So we say, okay, the perimeter is 4 times a side, and the side was 4 square root 2 feet. So when we multiply, we're going to get 16 square root 2 feet. And we keep the radical there. We want to change from the name feet to inches. So we're going to multiply such that we lose the name feet and gain the name inches. Which one's bigger? Feet. How many inches are in a foot? 12. We leave it alone because it's inches to the first and feet to the first, so it's 12 to the first and 1 to the first, which stays 12 and 1. The name feet cancels. We multiply. 12 times 16 is 192. we gain the name inches over 1, which is 192 inches. Any questions on example 3 for the squares? Okay. So we've got the basic formulas: area equals side square, perimeter equal 4s. We've got all the properties of a square. There's a whole bunch of them, about 11 or 12 of them. We need to know about the diagonals, the properties of the diagonals, and what the diagonals do, because that's kind of how we figure out all those 45, 45, 90 triangles. And then obviously we need to know our special right triangle rules. We also need to know how to do conversions using dimensional analysis. So lots of stuff to know how to do here. Okay. Okay, let's look at rectangles. We do need to know that the perimeter is the sum of the exterior sides. It's the distance around. That's something you're supposed to already know. I'm going to wide out down here where all the work goes for these rectangles. We're going to find the area. On the first one, remember we wanted the perimeter, and it asked for the answer in inches, so there's no conversions. Okay, the formula for area of a rectangle is base times height or length times width. We called it base times height because we wanted to see a triangle's half of that, half base times height. Trapezoid is half height, sum of bases. Parallelogram, base height. So as we compare the other area formulas to a rectangle, it's better if it's in base height form instead of length width form. Okay, so we're going to use base times height for area of a rectangle. So we want area. So the first thing we would do is write out our formula, base times height. In Algebra 1, I would have you put it on a word sentence line. And then we would plug into that formula, area equal base, 12 inches, times height, 4 inches. You know the height has to be perpendicular. We know opposite sides of a rectangle are equal. So the base is 12 and the height is 4. Height is straight down perpendicular. We learned in Algebra 1 on page 5 how to multiply. We said you multiply the numbers and you multiply the names and you get a new name. And when you multiply with like bases, you add the exponents. Even with units of measure, we're using that exponential law. It wanted the answer in inches, so we don't have to convert. So there's our answer to area. Perimeter is 4 times the length of a, I'm sorry, that's weird. The formula for perimeter of a rectangle, it's the distance around, so it's 2 lengths. Plus 2 widths. If you go all the way around, add up all the sides, you're going to have 2 lengths plus 2 widths. So the perimeter is equal to 2 times the length, 12 inches, plus 2 times the width, 4 inches. Now let's look at how the algebra works. When we use that name inches, it works like a variable x. We would say, can I do anything to simplify? Yes, I can multiply before I add. So I multiply, so I'm going to get P equal 2 times 12 is 24. The name tags along inches. Plus 2 times 4 is 8. The name tags along inches. Now I'm going to add. To add, they must be like terms. Those are like terms with the name inches. When you add or subtract, the name stays the same inches. We don't make it inches square. When you add, the name stays the same inches. 24 inches plus 8 inches is 32 inches. So the perimeter is 32 inches. Notice again, That perimeter is one dimension. Length, it's the distance around, which you could stretch out into one big long stretch, 32 inches. Area is two dimensions, and it's measured in square inches. Area, just to remind ourselves, is how many square units. So it'd be like we busted this into 4 sections, and the other would be 12 sections. I didn't do a very good job there. And so we want to know how many little square inches there would be. And there would be 12 times 4, which is 48 of those little square inches. I didn't make enough lines probably, so, but anyway, you get the concept. All right? All right? Okay, number 2. Number 2, we're looking for the area of the rectangle. Area is base times height. So we go to plugging stuff in. Area equal base, which we don't know, times the height, which we do know. The height is 10, so we don't know the base. We do know the height is 10. We cannot find area until we have base. But if we look at half of that rectangle is a right triangle. We know two sides of the right triangle, so we can find the third side by using the Pythagorean theorem. So we're going to say c squared equal a squared plus b squared. The c is the one across from the right angle, 26. So 26 squared is equal to my base of my triangle square plus the other leg, 10 squared. I know I'm using a squared plus b squared equals c squared, but I'm going to call that one side b. So we get 26 squared is 676 is equal to the base square plus 10 squared, which is 100. We're going to undo now addition by subtraction. Now we're going to undo the square with the square root, and so we get the base is equal to 24. So area is base 24 times height 10, and so the area is 240. Let's see how we got that. Okay. Number 3. Area of a rectangle is base times height. So we get area equal base, which we don't know again, times the height, which we do know. The height is 8. We can't find the area until we find the base. We only know one side this time, so we cannot use the Pythagorean theorem. The angle given is not a 30, 60, 90 or 45, 45, 90, so we can't use the special triangle rules. So we have to use a trigonometric ratio in that little right triangle on the bottom half. To find the base. When we do that, the first thing we do is write down the acute angle we're dealing with, 35 degrees. We look at the sides given and what we're trying to find and see how they're related to the angle that we chose. They're both legs. The base is the leg adjacent to the 35 because it's one of the sides of angle 35. The 8 is the leg opposite the 35. Leg opposite, leg adjacent is the tangent ratio. So we say tangent 35 equal. To set up the fraction, we do what tangent ratio says. Tangent says you put leg opposite 8 over leg adjacent, which is our base of our triangle. To solve, I'm going to do anything I can, or I can just wait to the end. What's this? I'm going to make this a proportion. I'm going to cross multiply that proportion. When I do, I'm going to get tangent 35b is equal to 1 times 8 is 8. I'm going to now undo multiplication to get that tangent 35 off of b. We undo multiplication by division. And I get b equal 8 divide tangent 35, and then I don't have to round as I go. So I'm going to do 8 divide tangent 35, 11.43 if I round right there. That's 5 or more, so you add 1, 11.43. So my height is 11.43 rounded to 2 decimal places. And so then I'm going to multiply, and I'm going to get area equal 11.43 times 8. And I could have not even rounded that and just multiplied by 8, right? To stay even more accurate. That's 91.44. I believe in the teacher's edition, I rounded that to a 0.4. But anyway, 91.44. For the area, or somewhere thereabouts. I've got 91.2 in the teacher's edition because I rounded to 11.4. So if you never round to the very end, you're going to be more and more accurate, okay? All right. So we had some squares and rectangles. We're going to look at the daily work. We'll do a few of these. Let's just do number 2. It has some conversion there. Just try to focus on the one we got. Get some of this other stuff out of the way. We want the area in square feet and the perimeter in square feet. Now, the formula for area of a square is side square. So I need a side, but I don't have a side. I do know, though, if we draw a in a square, that each angle was 90. The diagonal bisects a pair of opposite angles, and so I get a 45, 45, 90 triangle. In a 45, 45, 90 triangle, the length of the hypotenuse is equal to the length of a leg times the square root of 2. I put in my hypotenuse here, 6 square root 2 inches is equal to leg S times square root 2. To isolate the S, we're going to undo multiplication by division, so we're going to divide square root 2, and I'm going to get S is equal to 6 inches. So each side of the square is 6 inches, so my area is 6 inches quantity square. Exponent distributes on the multiplication, that's 6 times inches, which gives us 6 squared is 36 inches squared, or 36 square inches. But we wanted the answer in square feet, so we need to lose the name square inches and gain the name square feet. So we think, well, which one's bigger? Well, feet. So we have one of those. How many inches does it take to make a foot? 12 of those. But we're not dealing with feet and inches. We're dealing with square feet and square inches, and so we square the conversions. 1 squared is 1. 12 squared is 144. We're losing the name square inches. So we multiply 36 times 1 is 36, and we're gaining the name square feet. 1 times 44 is 44. 36 144ths. 12 will divide into both of those. 36 divide 12 is 3. 144 divide 12 is 12. Obviously, something bigger would have gone. 3 will go, so 36 would have gone, but 3 goes into 3 once, 3 goes into 12 4. So we should have divided by 36. And we get 1 over 4 square feet, which as a decimal is 0.25 square feet. Okay? So a fourth of a square foot or 0.5 square feet. Okay? Perimeter. That was area. The formula for perimeter is 4s, P equal 4s. We figured out the side was 6 inches, and so we have 4 times 6 inches, which is 24 inches for perimeter in inches. But we want it in feet, so we need to lose the name inches and gain the name feet. Lose the name inches, gain the name feet. Which one's bigger? Feet. So we have one of those. How many of the little ones inches does it take to make a foot? 12. We are dealing with feet and inches to the first power, so we leave it 1 to the first is 1, 12 to the first is 12, so we leave them alone. You can cross reduce here if you want. 12 goes into 12 once, 12 goes into 24 2, and so you end up with 2 feet. Okay? Any questions on number 2? Now, you may have read the directions and seen that it says round to the nearest tenth, and it is important to read directions. And we didn't round to the nearest tenth. If we round to the nearest tenth, the 2's in the tenth place. The 5 is the next number to the right. It's 5 or more, so you add 1 and drop the 5. So to the nearest tenth of a foot, this is 0.3 square feet. Okay? All right, be sure and answer according to the directions. Read all the fine print. Okay? All right. We'll let you play with the rest of those squares. On the rectangle, what are you going to use to find the missing part here? What are you going to use to find the missing part here? Don't forget about Pythagorean theorem and the trigonometric ratios, sine, cosine, and tangent. So you're going to be using those a little bit, okay? If the top on number 5 is 12 centimeters and the bottom is 12 centimeters, that's a right angle. You can find your height with the Pythagorean theorem. Here your height is 5, but to get your base, you're going to have to use this right triangle. You don't know two sides, you can't use Pythagorean theorem. It's not 30, 60, 90, 45, 45, 90. So you have to use sine, cosine, or tangent, one of the trigonometric ratios, to find the base. The first one, you're measuring in inches. It wants the answer in inches, so there's no conversions. The second one is in centimeters. You're going to square millimeters, so don't forget about your conversion. And the third one has no units, so you don't have to worry about conversion. Okay? Now, let's look at some of these questions down here. We got some word problems with some percentages that deal with some of these areas and volumes. And so let's kind of get used to some of this. It says, what is 45% of the area of the square with a diagonal 8 square root of 2? So we want 45% of the area. Of a square. How do you find 45% of something? Well, you multiply it by the decimal value of it, 0.45. Of means times. So 45% of the area of a square, which is side squared. So if we can find the side and square it, multiply by 0.45, we'll find 45% of the area. But it didn't give us the side, it gave us a fact, and the fact was that the diagonal was 8 square roots of 2, so we'll put that in a picture so we can kind of think about it. If we draw a diagonal in a square, we get a 45, 45, 90 triangle. We need the length of a side. We're going to use the 45, 45, 90 triangle formula. Hypotenuse is equal to leg times the square root of 2. So hypotenuse, 8 square root 2, is equal to leg S times square root 2. To isolate the S, we're going to undo multiplication by division. And we get side is 8. So we plug that in. We get 45% of 8 squared. You do exponent before multiplication. 8 squared is 64. 45% of 64 is 0.45 times 64. Just going to use the calculator here. 0.45 times 64. 28.8. We had no units of measure, so that's the area. Any questions on number 7? Okay. Let's just look at number 10. Let's try to scan and see which one I wanted. Sorry about all the wiggling of the screen there. Number 9 may be a little challenging, but it's in the odd answers, right? So you can go look at that and kind of figure that out. We want the area in square centimeters of a rectangle with a base of 40 millimeters and a height of 26 millimeters. So we want the area of a rectangle. The formula for area of a rectangle is base times height. So we get area equal base, which is 40 millimeters, times height, which is 26 millimeters. You multiply the numbers and you multiply the names and you get a new name and you're going to get so many millimeters square. And then you want to lose the name millimeter square. Gain the name centimeter square. And I'm leaving some things for you to finish, so that'll get you started, right? Let's go ahead and do number 11. Number 11 is a good standardized testing type question, and we had some of these like this in the algebra book to try to get you ready for that. So let's just go ahead and, even though it's an odd answer, we'll go ahead and do it. Remember in my Algebra 1 text on page 40, we said how to do word problems. We said we'd read and understand the story, identify the character or characters of the story, and assign a variable to each one. We're going to write out word sentences, which could be a comparison between two characters, B, formula words like perimeter, area, volume, or C, sentences containing words like total, sum, difference, product, quotient, etc. We'll change those word sentences into mathematical equations, solve using the order of operations, check to make sure the answer makes sense to the story. It says length is 6 more than width. We know that that is a comparison between two characters. So we say L is 6 more than W. And then it says perimeter is 78, and that's a formula word. And so we put the formula word, the verb, and the result. Soon as you see that you have a formula, you look up the formula. Formula for perimeter of a rectangle is 2L plus 2W. You need to know that from memory for my class, but it is on the formulas chart on most standardized testing. The characters of the story are the pieces of the word sentences. What we're dealing with is length, width, perimeter, length, and width. So the characters are those unknowns, length, width, and perimeter. We're going to call length L. We're going to call width W. Perimeter has been called P. But we know the perimeter is 78. So we read and understood the story. We identified the characters of the story. We found those characters in the word sentences, which could be A, comparison between two characters, B, formula words like perimeter, area, volume, circumference, etc., or C, sentences containing words like total, sum, difference, product, quotient, etc. We're going to change the word sentences into mathematical equations. For subject, verb, we put subject equal. The verb means equal. 6 more than means that I'm gaining. What I'm gaining goes after the plus, and so the 6 goes after the plus. 6 more than what? W. You can see page 37 for how to change word sentences into mathematical equations. Page 37 of the Algebra 1 text. So we have two formulas. On this one, instead of putting P equal, since we know what the perimeter is, we would put 78 equal. We have a system of two equations with two unknowns. We're going to solve by substitution. So we take what L is in terms of W, and we're going to put that in place of L in the other equation. So we would have 78 is equal to 2 times what L is. Now we're replacing L with a sum. Rule 2, page 37, and distributive law says if you multiply something to or divide something by a sum or difference, you have to put that sum or difference in parentheses and distribute. But you only distribute it if it's a one lesser operation. So when we replace the L with the W stuff, we put it in parentheses, and then we still have the plus 2W. So now we have an equation with only one variable W. According to the order of operations horseshoe on page 33 of my algebra text, we said this. We're going to do anything we can to simplify. That's where we put the little green arrows. In the order, please excuse my adherent Sally. looking for distributive property and combining like terms. So we're going to distribute. 2 times W is 2W. 2 times 6 is 12. And we still have the plus 2W. Again, we say, is there anything we can do to simplify? In the order, please excuse my dear Aunt Sally. When you're down to addition and subtraction, you look for combining like terms. So we're going to combine like terms. 2W plus 2W is 4W. When you add, the name stays the same, so you leave it W to the first, plus 12. There's nothing else we can do to simplify, so we do the bottom of the horseshoe. It says get the variable you're isolating on one side, but there's not a variable on both sides. So we move to the right side of the horseshoe, which is to undo. We're going to undo addition first by subtraction. And so we get 4W is equal to 66. We're now going to undo multiplication by division. And we're going to get the width is equal to 15 and a half. We got the 15 and a half. We did 66. Divide 4. It goes 1, 4. With 2 left over, bring down a 6. It'll go 5 times. Whoops. That's a 16 and a half. I don't know if I said 15 or 16. So 6 times 4 is 24 with 2 left over. You could put your remainder 2 over your divisor 4. So 16 and 2/4 are 16 and a half, or 16.5. Okay. So the width is 16.5. If we want to find the length, we can plug it back in here. The length is the width 16.5 plus 6. So the length is 22.5. If we think you got the answer, read the question again. It says find the area, so we don't have the answer yet. See, I skipped the word sentence. I should already had that on a word sentence line, right? The formula for area of a rectangle is length times width, or base times height. We found the length and width, so we can plug them in. So area equal length 22.5 times width 16.5. So we're going to have 22.5 times 16.5. $371.25. Any questions on number 11? Okay. So we've got our formula stuff going on, but we're also going back to those old word problem type things from Algebra 1. What's next is a lot more drill and practice, which you need that drill and practice. And we're going to leave those things with you. Some of the last word problem is an odd answer one, and we're going to kind of leave that with you too. So you can study that one out of the odd answers if you need to. Don't just write down the answer, and don't just copy the solution. You need to study that solution so you know what you're doing. All right, that's the end of 10-1.